Okay, hi everyone and welcome to our second Principles of Successful Blockchain Deployments webinars. I'm Conor Svensson, the founder and CEO of Web3 Labs. First, before we get going, we wanted just to do a little bit of housekeeping. We've got some more people joining. Just let them in. Before we kick off things properly, I wanted just to do a little bit of housekeeping. I'm really keen for these sessions to be interactive. So if anyone wants to, unmute to actually ask questions as we go along, I'm always happy to answer any questions that people may have. Likewise as well, if you want to stick any messages in the chat, we'd love to actually, make it an interactive session rather than it just be one-sided, me talking. That's one of the reasons why we host this in a sort of as a Zoom meeting rather than a sort of webinar, so that if people want to, they can engage in a way that you can't with a webinar. It's certainly more fun when we can have an active discussion here. Today's session is being recorded. Now, who's actually here? No details of the attendees or anything like that will be on the recording. Of course, if you choose to talk and say, what your name is and what your company is, then of course that information will be there. But again, if you're there in the background, just listening, taking in the content as we go through it, then none of that information will actually be on the recording as such. So just to let you know before we actually kick things off properly. Okay, so in terms of the actual format of the webinar, it runs for, we have an hour slot, but really the webinar is going to run for sort of around, half an hour, 40 minutes in terms of the core content. And then there's plenty of time at the end for Q&A. As I said, I would rather, make it a more interactive session, give people the opportunity to talk to us and, answer any burning questions that they might have, rather than it just be, us throw information over at you. Right. So just letting in people as they join. Okay, so without further ado, anyway, we'll actually kick things off properly now. There we go. Sorry, just else coming in. Okay, so hopefully everyone can see my my screen okay. If you want to give like a thumbs up on the chat, or just put something there, please feel free. Just to give you some background first of all. So I'm Conor Svensson. I'm the founder and CEO of Web3 Labs. We're a blockchain technology company. I was the original author of the leading blockchain developer library called Web3J, which is coming up to 1 million downloads since it was first released a few years ago. I hold a number of key roles in major blockchain industry organizations. I was the chair of the technical specification working group for 3 years within the Enterprise Ethereum Alliance, where we are responsible for building the first ever technical specification for Enterprise Ethereum. I'm also on the technical steering committee currently of the baseline protocol. I am the vice chair of the Interwork Framework Working Group at the Interwork Alliance, which is an organization focused on standards for business processes that support DLT. And I am also a regular contributor to the Hyperledger Climate Special Interest Group. In terms of Web3 Labs, we've worked with a number of different clients across the blockchain as well as the conventional spheres as well. So that includes Microsoft, J.P. Morgan, ConsenSys and R3, amongst others. We're also a runner-up in Microsoft's Partner of the Year awards last year. We've received grant funding. We've been awarded grants, awards from Innovate UK and the Ethereum Foundation too. So enough about me and the company. What we're here today to talk about is these core principles. And so these principles really came from our work over the past few years, as Web3 Labs, of working on a number of different blockchain projects and initiatives with, different organizations of varying sizes, from kind of small startups right the way up to, some of the largest companies in the world. And, we really believe that there's kind of 3 core principles that, people and companies should abide to help ensure that, you know, when they're working with blockchain technology, be that a proof of concept or actually going live in a, you know, production context at a significant scale, but by abiding by these principles, then it puts them in a position to maximize the chance of success. On the surface, yes, it appears, you know, quite straightforward, but I think, you know, as with all these things, as you go into the detail, there's some very specific points and views that we have here that, again, we believe will ensure that people kind of, you know, go in the right direction when they embrace this technology. So the first one of these is, you know, the actual target use case, ensuring that you are actually, you know, looking to address a problem that blockchain's well suited to. The other is the technology stack, and, you know, there's a lot to choose from here, and it's very important that, you know, when you're working with it, that you select the right platform for your organization, because as with any technology, there's a lot to choose from and you can lose a lot of time selecting the wrong ones. And then finally, there's the team considerations. Of course, yeah, you can outsource work to actually, you know, deliver these projects, but even if you do or don't, there's certain key competencies you need to ensure you have in the teams that are, you know, whether they're internal or external, delivering on these blockchain projects, and that's what we want to go into some of the detail there. Like I said, please, if you have any questions as we go, do feel free to unmute yourself, and we can certainly stop to talk on any of the specific points. So the first principle that we're going to be talking about is the actual target use case. Fundamentally, the question here is, what problem are you trying to solve, you know, with blockchain? And here, you know, we want to kind of wind things back a little bit and kind of go back to first principles. From the business perspective, of course, you understand your own business very well, and you have a clear need that you know, you believe that blockchain may be able to help with your organization. But it's our belief that there's really three things that blockchain does exceptionally well. And so, you know, by focusing on the application of the technology for problems aligned with these specific use cases, I think you'll have a much greater chance of success, in that you'll be taking advantage of the capabilities that blockchain provides, but also you'll be, you know, you'll be fitting it in nicely to, you know, a real problem that your organization faces. So these are records of ownership problems, cross-party business process problems, and digital fingerprints. And I will go into each of these in a little bit more detail in the coming slides. On our right here, it's worth highlighting, we have this blockchain network image that we use to kind of, you know, represent the blockchain. And I think it's important that you have, you know, some common way of conceptualizing it. So at the heart, ultimately, a blockchain has some sort of shared ledger there. And, you know, it's not vastly different from a database in that it's storing data in some specific format. And then these boxes that are kind of pointing to it, they're nodes on the actual blockchain network that basically share that blockchain state among them. Now, depending on which blockchain or DLT technology you use, there are some, you know, subtleties in terms of exactly where the data resides. But from a conceptual viewpoint, it's certainly, it doesn't do any harm to think about it in this manner. So you have these four nodes, but of course there could be an arbitrary number of nodes, and they have some common ledger states between them. Okay, so records of ownership. So this you can think about where you have company A and company B. There is some sort of asset that company A owns that they want to transfer to company B. And again, when I talk about asset, it can be very arbitrary here. It could be a currency. It could be a specific commodity that they have on their books. It could be a product that they sell. But the point is that they have something on their own internal systems that represents that asset, be it digital or physical, and they want to transfer the ownership of that to company B. Now, historically, how this happens is that company A and company B will each have their own internal state that shows, you know, the ownership of this asset. And when it comes to transferring it, company A will send a message to company B, and then they'll both need to reconcile that transaction independently after the fact, because they each have their own worldviews. If we have a blockchain there, the big difference is that this transfer of asset ownership goes via the actual shared ledger part of the blockchain. So company A initiates the transfer, and then it goes onto companies B's books within the actual context of the blockchain network. So there isn't this notion of actually having to separate out these different systems that represent the states across company A and B. We have this blockchain network, and that blockchain network is the source of truth. So if that transfer goes through that, then both companies A and B, or however many other companies on the network, can see details of that asset ownership. And so this is a significant simplification, for companies, because there's basically one place they need to initiate this transfer, and then everyone else on that network, if they're permissioned appropriately, can see that that has actually taken place. And this is, where you see, if these cryptocurrency assets, for instance, they exist on a shared ledger, so ownership of them from one person to another, or one company to another, all takes place in that single network. And it's exactly the same with any sort of asset that you want to represent on a blockchain. So these core characteristics of, when you actually want to think about this specific use case, it's where you've got a digital version of a physical or already digital asset, and you have some sort of registry of ownership associated with it, and there is a notion of tradability for it, i.e. it can be transferred from one individual to another individual. And so there's a number of different sample use cases where we've seen this being used as well. So in the ESG sector, which is environment, sustainability and corporate governance, we see it in emissions offsets. So the World Bank, for instance, they're doing a pilot currently where they're representing actual carbon offsets in a tokenized format that can actually be used to demonstrate these emissions offsets where they've been created, but then also the companies that invest in them to actually reduce their greenhouse gas emissions. We also see it within the energy commodity trading. There's a company called VACT, that's VAKT, which actually provides commodity trading of crude oil, and they use they basically use this record of ownership type model to represent these barrels of crude. We see it too in the supply chain space as well. One example here is Starbucks with their coffee bean provenance, basically where when a coffee bean is harvested all the way through to when it actually gets ground up and made into a coffee, they have traceability of those coffee beans going through their entire supply chain. So from the producer to the consumer can actually see where their coffee beans have come from. In the financial space as well, of course, there's a great deal of interest there. Again, multiple use cases. So, interbank settlement, where you have one bank paying another bank. This is a great opportunity for this kind of this digital asset, because otherwise what they're doing is they're sending funds to one another, and then they have to reconcile their own records independently of those fund transfers. Whereas using a distributed ledger, then it means you can have like a single source for this. We also see it's exactly the same application in central bank digital currencies as well, which is a huge area of growth at the moment. For instance, the Bank of England right now, and a number of different major governments are actually really pushing to explore the CDBC, as they're called, use cases using distributed ledger, as it's considered to be a significant efficiency gain that the financial industry can have. And then as well in the private market security issuance space too, the depository trading, the depository, the DTCC, the Depository Trade and Commodities Clearinghouse, basically, they hold information about the vast majority of the world's swaps transactions, but they are also looking at use cases where they can actually have private market securities issuance. So if you have a company that's not big enough to be listed on a stock exchange or public exchange, but they want people to invest in it, then you have these private markets where they take these securities to it could be wealthy individuals or hedge funds or these other types of investors, and give them a way to actually invest in it, where there's a token that represents that security issuance there. And then, of course, we see it in terms of land registries. The UK Land Registry has, and many land registries in many other jurisdictions as well, have actually, tokenized or digitized this notion of ownership of properties, and then the transfer of ownership, with an actual residential as well as commercial property transaction has actually been performed via the blockchain. So these are just some of the use cases where we're seeing this being used, and of course it spans like a very large number of use cases across a number of different industries. Again, I will stop there just in case anyone has any questions that they wanted to ask, as we go through this before I continue on. Okay, so the next use case that we're going to be talking about is what are called cross-party business processes. And so really you can think about these as just complex business processes where you have, be it 2, 3, 4, however many businesses involved in a transaction. And so here we try to distill it down into a very, a simplistic workflow, just so we're not going, too far down a specific, industry use case. But the idea is that you have this blockchain network, and company A sends some request into it, and company B needs to, approve something to happen before company C can, receive some result there. So, if we actually kind of contextualize this is more about where you have complex business processes that require an intermediary to actually sit in part of the transaction. So this is a very, very common thing that we see in business. A classic example here is with a, with some sort of security. I know we touched on them in the last use case, but it's also applicable here as well. So where you have a what's called a securities clearinghouse, i.e., if someone buys or sells a stock, say in Apple on an exchange, or sorry, a company buys or sells a stock on an exchange, then the exchange of ownership will actually go through an intermediary to make that happen. And so, what this means is that there's, all these transactions that are taking place where instead of going, transferring something from one person to another directly, it has to go through some sort of intermediary. And so this is a classic example of a cross-party business process. But another example is in the supply chain space as well, where maybe, you have some goods that are going via ship and by container on a ship, and as they kind of at each sort of hop along the supply chain, there's different companies involved in that process that basically need to say, that stamp that they've done their specific job, and that end-to-end process. And again, this is something that requires a lot of independent communication between the different companies, on that transaction of getting this asset from, company A to company B. And so this is another place where we have these sort of complex or cross-party business processes. So the characteristics here, as I said, it's where you have these multiple external entities talking to one another. So incredibly common when you get to larger companies, especially where they're doing these things at scale, and their business is very much so built on their relationships with a number of different suppliers as well as customers. And typically, you have this notion of a trusted intermediary who's sitting behind the transactions. So we're going to, to run through some specific use cases here. In the supply chain space, we have this notion of a digital bill of lading, which is, when some sort of commodity or cargo is going on a container ship, you have this, typically it's actually a physical piece of paper that says exactly what it is that's being transferred. A company called Comgo have actually digitized that using a blockchain. There's also the fact that it can provide a lot more transparency along the supply chain as well. So the Coke One, who's one of the major Coca-Cola distributors in the US as well, is They're actually now on their second iteration of their, of using blockchain in their business there. So again, where you have these distributors that they're working with to actually distribute Coca-Cola to, they're making use of a blockchain-based supply chain to support that. In the financial sector as well, we see it, say, in insurance claim management. When someone takes out an insurance policy, there's the organization that actually sells the policy, but then there's the insurance company that underwrites the insurance policy. And then there might be a separate company, or often it is the underwriter who deals with the actual claim management. So if someone buys this policy and then they subsequently need to make a claim, there's kind of these communications that happen with the seller of the insurance policy as well as the actual underwriter as well, and potentially a separate claims department. Again, it's a complex process. Using a blockchain enables you to actually have a single place where all of these different actors interact with one another, instead of platforms, say, being shared between the underwriter and the actual seller of the insurance product. And then as well, another huge opportunity and use case for it is financial reporting and reconciling. Microsoft's Xbox division actually used this to great effect with respect to paying royalties to the publishers who are actually selling content on the Xbox Live platform. So typically it would take actually publishers around about 30 days to actually receive payments from for what they've sold on the Xbox platform, just because there was all these different fragmented systems internally within Microsoft. They moved this onto a blockchain that spans multiple divisions of the organization, and that actually managed to get them down from having this 30-day process to actually pay royalties to these publishers, to getting it down to a few hours. So again, it's kind of talks to the transformative potential of it. And it's worth saying too, we talk about cross-party business processes, but these processes can be within a single organization as well. When you have a large corporate that has multiple entities spanning multiple different geographical regions, they are almost like separate companies into themselves, because they have their own governance structures and leadership and their own corporate structures supporting them. But again, you can't have this notion of like a shared database using conventional technology within them. They wouldn't even know, say, what cost centers they go to. Whereas you bring in a blockchain, there's a way for a very large distributed organization to actually have that kind of transparency within the business, as the Microsoft's Xbox use case is a great example of. So the third use case that we were going to talk about is digital fingerprints. So this is basically where you have some sort of data being captured, be it physical data about some surroundings, say in a detection system of some sort, or it could be digital data that's sampling from some sort of source. But the point is that you want proof of the data that was captured at source. And so typically, this means that you have some sort of data capture application, and then some data gets written to the data store. But what you can do as well is you can create a hash of that data, which is basically a cryptographic signature of that data, and write it to a shared ledger. Now, the advantage of actually writing it to a shared ledger then is it's basically a way of irrefutably proving that some event took place, because you can only reproduce that data that you've put onto the blockchain by actually providing this exactly the same input data. So it's a great way to sort of prove that the integrity of some data, that some events that says claims that took place did actually take place. So the characteristics of this are where we want to really prove that some activity or event took place, but also we can use it as a type of evidence for dispute resolution, and we can take advantage of the immutability properties of the blockchain, in that it's tamper-proof as well here, which is very powerful. And this is something that we've seen being used again in many different use cases. So in the digital rights management space, if you have any sort of digital content that you're the creator of, it could be music, it could be digital art or whatever else, you can actually create these hashes to show that you were the original creator of that piece of work. We've seen it as well, like with the LVMH group that owns like Louis Vuitton and various other luxury goods. They've actually using blockchain for authenticity guarantees of their luxury goods. In the utility sector as well, so Vodafone have actually partnered with a blockchain group called the Energy Web Foundation, where they actually use secure IDs that reside on a blockchain to identify their grid energy assets. So you could have like some solar panels that are contributing to a power grid somewhere, and the identities of those, as well as the data that they're sending in, is actually residing on the blockchain to show where it's originating from, and that they were the original contributor who put that power on the grid in the first place. We see it as well in the commodity space. There's a company called Expansive, and that's spelt with an X, and they actually are creating this notion of fingerprints for commodities. So, when typically, commodities are considered a very fungible asset, in that, you have soybeans from one producer, they're treated no differently in the market to soybeans from another producer. But maybe you want to understand how sustainably the farmers of those soybeans are actually being in their practices. By giving them a actual unique fingerprint at the point of production, you can trace those back to the actual creator of them. And again, so it's a very powerful concept there. In the world of finance, when it comes to actually creating agreements, and this is somewhere else where we see it a lot, is just in digital versions of documents. You create a digital fingerprint of it, and so an example here can be financing agreements. For instance, one of the companies we work with, they produce financing agreements for heavy pieces of equipment, and when you actually finance a piece of equipment, you want to ensure that there isn't already an existing financing agreement taken out on that, and that the financing agreement that you're seeing is actually the real financing agreement. And so by having a digital version of that, again, it's a very powerful thing for the for making use of the technology. And then finally, too, in the carbon registries, we're seeing it. So, when there's data that has been put in these national level carbon registries, if you can create a digital fingerprint of that data to show that, where it originated from, and then subsequently, kind of track it through its life cycle. So just to kind of recap what we've discussed there, that blockchain is very good at these three things, really, we believe. So records of ownership, so where you have some sort of asset, be that physical or digital, that you want to be able to trade between different people or companies. These cross-party business processes, so when you have a very complex process that actually spans the boundaries of multiple organizations. And then finally, as well, digital fingerprints, as we've just covered there. So, when you actually have some data, you want to be able to give it, be it like a digital watermark or some way of proving that an event took place at some point in time in the past. Okay, so moving on to principle number 2, we're going to be talking about the actual technology aspect of things here. So when we discuss, blockchain technology, one of the things that we're certainly discussing is what is the actual platform that you're choosing to work with. And so I think there's kind of two underlying considerations here. One of these is that whether you're choosing what is a public versus a private network. And then the other is, once you've decided that, which one of those platforms you actually work with. So when we talk about public blockchain networks, we're talking about what is publicly available really to anyone who wants to work with those networks. So these are widely available networks that run on the internet, basically, and there isn't really a sort of barrier to entry to work with them as such, other than engaging with the cryptocurrency that they provide, which is typically what is used to pay for transactions with those networks, but is also the store of value that resides on them. So Bitcoin and Ethereum, they're the best known of these, but we also have other ones like Ripple, Polkadot, and Cardano. But the key thing here with these is that they run in the public domain, but also they have significant they have significant value associated with them. So I'm sure these numbers have probably gone up further in the last few days since September when they were taken. But the Bitcoin network has over $2 billion of Bitcoin residing in it, and Ethereum, which is the second largest, has over 40 billion. And of this, you have roughly 10 billion actually locked in applications running on top of it. So these are big numbers, but this is really testament to the belief in the stability of the technology. Yes, it is emerging, and yes, it is running in a public place where really anyone can play. But at the same time, these sorts of figures are testament to the confidence that people have in the actual technology. So public networks, this has been a big driving force with blockchain technology, but they do come with a number of challenges as well. And one of those, because it is a public network, you're at the mercy of what's happening in this public network when you actually try to work with it. So it's certainly not where we recommend people start if they actually want to run business-focused applications. We think that it's a much safer bet to actually work within a private network, which we'll talk a little bit more about now. So a private network is one is typically consortia driven. So there's huge numbers of different consortiums that already exist in businesses covering all sorts of different industries, be it healthcare all the way through to supply chain and finance. But there's three properties that typically we see that that organisations and enterprises require when they actually want to engage with these networks. One of them, of course, is that it's private. If you have a sort of a ring-fenced consortium, you don't want anyone to be able to join a network that's there for that consortium. You want to have confidence in who the other actors are that are working on that network. You also want to ensure that it's permissioned as well, so that there's clear controls in place, so that once someone is in the network, there can still be actual restrictions there in terms of what they can actually do with the network. And again, with these public blockchain networks, there aren't really any restrictions. If you have cryptocurrency, you can play ball in those. And so that, again, is not something that private consortiums typically want anyone to be able to join, because there's a certain cost for doing business with them, and they want to work with those other companies that they're comfortable working with. And then finally, we have the performance considerations as well. These public blockchain networks, they do handle very large transaction volumes each day. We are talking in terms of like the millions, but that being said, they can't handle the kind of hundreds of millions of transaction throughput that you're seeing a lot of sort of more enterprise focused use cases for networks. One of the other side notes as well with that too is that enterprises typically want consistent performance too. If you're working with a public network, if for whatever reason there's something running on the network that's slowing it down, then that's going to affect everyone on the network. In a private consortium setting, you know who the actors are, so it gives you a bit more control there. So when we talk about the private platforms, there's really three main platforms, and then there's also a fourth framework that I'll mention too. But these are the platforms based on Ethereum, which includes Hyperledger Besu and Quorum, which originally came from J.P. Morgan. We also have Hyperledger Fabric, which is IBM's blockchain technology, R3 Corda, which is another generally more finance-focused platform. And then we have Digital Assets DAML, which is basically a smart contract development language that runs across multiple blockchains. There are many other private blockchain platforms, and as with all technologies, there's different there's different trade-offs with the platform that you actually select. I'm not going to be going into a lot of detail about those, but that's certainly things we can talk to people about. But the key takeaway here is that our recommendation is that you stick with one of these three if you're looking to do a blockchain project or implementation, simply because they're the most tried and tested, they're the most widely used. And to give a bit of substance as to why I say this, I think that what Forbes produced now, which is the blockchain 50, is a great reference point here. So this is really some of the world's largest companies. They have revenues or valuations in excess of $1 billion USD. And these are the different platforms that they're using, and so you can really clearly see here that it's Ethereum or Quorum or Hyperledger Fabric or Corda, and so they're really the ones that dominate. Yes, Bitcoin's there, but then Bitcoin doesn't offer the same development opportunities that the other three platforms do. So again, we really believe that at this point in time, it might change in the coming years as other platforms start to get a greater user base, but we're talking about maximizing your chance of success here, and the best way to maximize your chance of success is to work with the most established platforms, the ones that have been the most battle tested within enterprise settings, and these are those three. Okay, so moving on to our third and final principle. This is where we talk about the actual team capabilities. And so we need to ensure that you have, the right capabilities within your organization or with the provider that you're using to actually, to deliver this project. Again, just, general advice there, if you are going with an external company, if they can't kind of tick off all of these criteria, then, you really should be looking elsewhere. And so, we just want to make sure you're looking at it from the right perspective by talking about it here. So broadly speaking, there's three considerations here. One of them is the actual platform deployments. With these, not only do you need to develop these platforms, but you also need to have a mechanism by which you can manage them and actually get them live on your infrastructure. And so that's an important consideration there. Then when it comes to actually developing the blockchain applications, you have to consider the actual smart contracts in terms of the code that runs on the blockchain, but then you also need to consider the integrations in terms of how you talk to those applications that are running on these blockchain applications, because they don't just, it doesn't all just magically work like existing code. And then as well, you have the security considerations. So it's really, really important that you don't ignore these, because yes, it's fine if you're doing like a basic proof of concept, but if you want to go to production here, you've got to make sure you can account for these. So this covers the actual management of keys or wallets that are used to transact with these networks, and then the actual physical connectivity piece as well to these networks. So when we talk about the platform deployment, really what we're thinking about is, how the actual platform is run. And there's really three broad options here. So the first one is like, it's the do-it-yourself. It's the self-hosted, where you actually deploy the network yourself and deploy all of the nodes and write all of the, the orchestration code in order to do that. And this typically requires dedicated, what are called DevOps resources. So these are what were once upon a time your Unix and Linux sysadmins, basically the people who really understand how to provision infrastructure. But it is important that they actually understand how to provision blockchain infrastructure, because time and time again you'll see people take on a blockchain project, then they don't realize quite how complex it's going to be to actually run the network and manage the network. And so we really encourage to make sure you have dedicated staff to focus on just that part in addition to the actual application development. Then if you want to take away some of the pain there, you do have cloud-hosted, blockchain as a service offering. So, Azure have one, AWS have one. This is basically where you've got like an interface where you can deploy a blockchain in the same way that you can deploy a new database on these cloud vendors' platforms. And so again, it's not as resource intensive as managing it yourself, but again, you're still relying on the cloud infrastructure provider to do it for you. And so typically they do a good job, but there will also be trade-offs in terms of how much hand-holding there is to actually get you up and running. And then finally, you have the fully managed services, and this is where you actually have, it's much more a traditional SaaS type offering, where it's, you sign up through a portal to the product or service, you point and click and say, give me this blockchain network, and then it's done. Two of the leaders here in the space are Kaleido and Chainstack, and they support a number of those ledgers that we touched on previously. The next piece is the actual development of the smart contracts themselves. Now, what you'll see here is that there's no common language that works across all of the different blockchain platforms. On the left, we have our Ethereum variants. On the right, we have Hyperledger Fabric, and at the bottom, we have Corda. And each of these different platforms has their own kind of requirements in terms of what you actually use to write these smart contracts, which is the code that runs on the blockchain. And so, Fabric is the one that most supports the most conventional, well, the widest number of conventional programming languages. Corda is just focused on the Java virtual machine. On the Ethereum side, they use a language called Solidity, which is a unique language. Now, the thing with Solidity is it's very, very widely used by the largest blockchain community, which is the Ethereum community. And so although it is a new language, it's one that is very well understood and has got a lot of code holding a lot of valuable assets in the public domain. Hyperledger Fabric and Corda, they do not have things in the public domain as such. It's more just these private permissioned blockchains where they support it, and they use these more conventional languages. But they're still, it's not straightforward just to go and write a smart contract application using them. You need to understand the nuances of actually working with the underlying blockchain platforms there. Then from the actual smart contract developments, we then have the integration side. And so, the actual integrations, that's another key consideration here, just because, there's a number of different there's a number of different integration libraries that you can actually use to talk to these different blockchains. And so because of Corda using Java, that's kind of the one platform that is common to all of these different languages. And also, it's very, very widely used in enterprise. But then, with Fabric, we also have JavaScript and Golang. But then Ethereum, and this is again is a reflection on the size of the community, has got the most options there. It has integrations really for all of the different major programming languages that are used. So again, you are making trade-offs here, and it might depend on the capabilities that your internal team has in order to help guide which the direction makes sense. But it's very important that you consider both the actual smart contract development process as well as the integration part, and that you don't overlook either one of those. The other piece of the puzzle is the actual security side of it. So this is where we have the key management. Now, companies are very used to actually managing credentials in a secure manner, and these blockchain platforms, they have cryptographic keys that are used to actually to actually transact with these networks. Sometimes you'll hear these referred to as wallets, but the key thing here is that they're just cryptographic keys. And so there's very well established patterns within businesses for actually managing these credentials. So one of these is what are called hardware security modules. These hardware security modules are basically tamper-proof physical devices where keys exist, and so they can be used to actually perform a cryptographic operation, but they cannot be exported. If they basically get tainted, if someone pulls the data off there, and then someone knows that key's been tainted. We then also have cloud versions of these as well. So Azure have their Key Vault service, Amazon Web Services have their key management service, but it's a similar concept. You have these vaults where they actually store these cryptographic keys or secrets. And then, alternatively, you also have secrets management tools. So these, one prominent example right now is HashiCorp's Vault product. But the point is that it's a service that is explicitly there for storing sensitive data. And so again, when you're looking at this blockchain deployment seriously, you need to ensure you're using one of these types of services to secure credentials associated with your applications. The other part of it is actually the network connectivity. And so, there's considerations here around how the different consortia members, connect to one another. Because, if you're a company, it's not always trivial just to, set up a connection to another company. You might have to go through, information security teams in order to actually get the all clear to do that. And so it's very important that you think about the actual physical challenges for these pieces of connectivity within your network, because it may be all well and good that you've developed your applications, but when it comes to going to a live production environment, you're waiting months for the InfoSec team to approve these, the creation of these connections. And so, again, it's very, very important that, you think about this stuff at the start, because yes, at one level, people can build proof of concepts, they can get them out there. But if you want to go all the way to production, you need to ensure that you have these info security teams on board early on, so that you're not subject to delays for actually getting these networks spun up, because it can get very, very complex quite quickly. So these are the three principles. So just to recap on each of these, we have the target use case, the technology and team that we've covered off here. So the target use case, of course, making sure that you have the right problem that you're trying to solve with it. And so blockchain is really, really good at where you have records of ownership, where you've got a digital version of a physical or digital asset that you want to represent, and this you can transfer between different individuals or companies. You also have your cross-party business processes, where you have these processes that span the boundaries of multiple organizations, such as what you see in supply chains, or the settlement of, say, a security. And then finally, we have the digital fingerprints, where you actually want to prove that some sort of activity or event took place. So it could be, a fingerprint, a digital fingerprint of a document, or it could be, like a proof that a luxury good that you're presented with is actually is authentic. We then touched on the different technology options here. So we spoke about, whether you choose a private versus public blockchain network. We also spoke about the different private platforms. We covered Ethereum, Hyperledger Fabric, R3's Corda. And then we also covered the team as well. So the considerations around, the actual platform in terms of the deployment and management, ensuring that you have the capabilities there to do that. We touched on the development, so making sure you remember that you need the skills available to develop smart contracts, but also integrate with those blockchain applications. And then finally, there was the security considerations, where we touched on the actual physical cryptographic key management and the connectivity to these actual networks. So where do you want to go from here? Now, we've certainly spoken about the considerations when you actually want to run with deploying blockchain applications. But I think it's also worth mentioning where Web3 Labs can actually come into the picture here. So, we have both consultancy and technology delivery services, where we can actually take projects from concept all the way through to production and provide training and support there. We've also written some very significant technology in the space, the Web3J development framework. We also have the Epirus platform for blockchains, which provides deployment information and for your apps and analytics. So we recently launched this Web3 Labs project delivery service. And so this really gives an opportunity for a limited number of companies to explore directly with us blockchain opportunities that really fit into one of these three use cases that we discussed here, be it records of ownership, digital fingerprints, or cross-party business processes. We take care of the platform development and deployments and provide a fully integrated solution, but also work with yourselves to ensure that you're targeting the right use case and that there's sufficient knowledge about the upside of actually working with the technology there. And our process to actually support this is split into a number of stages. So the first of these is to actually ensure that we really understand your business. And then, when we're clear on that part, then we can actually, start to drill the message home about, where blockchain can provide, tangible value to your organization. And from there, we align it with what both sides believe to be the right opportunity for the business. Once we actually have that, then we can go into the design phase, where we can actually outline a solution, and then finally actually build the application. And again, this is not something that takes multiple months. We're talking more, time horizons around the weeks, over a number of weeks for the actual process here. So really the emphasis here is on being able to turn something around quickly, and working very closely with the organizations that engage us. In order to take advantage of this, you can book a free 30-minute discovery session with myself. You can go to web3labs.com/discovery, and from there, basically, you can book a 30-minute session where we can just discuss, your specific use cases and find out really if there is a way that makes sense, to work with you. Given the use cases and the opportunities that you see, for blockchain within your business. So that's everything I was going to say. We have time now. We have 10 minutes for questions. So if anyone wants to stick around and ask any questions, then I'm more than happy to to go back and talk through any of these areas that I've covered. And if you'd like to have a follow-on chat with me, you can head to web3labs.com/discovery, and you can book a slot there to actually have a one-to-one chat, and we can explore opportunities in more detail. Yeah, so just with the questions here, one of them was, is it possible to share the slides? Yes, it is. If you can message me privately with your email address, or you can put it on the general chat. Alternatively, we will be sending out an email shortly after this to everyone who registered, where we have a link to the video, so you can actually play back this video. But if you respond to that, you can actually, I can send you the slides as well. I'd be more than happy to send you a PDF of those. And so with respect to the next question, almost every use case which blockchain is trying to solve can be achieved using traditional methods. What do you see is the challenge here? I agree to a point that you can achieve similar results using other technologies, but let's take it to a consortium setting. So if you have a consortium, and these consortium, they want to share data with one another. Now, if they talk directly to one another, if you have 4 members in that consortium, that means that there's basically 4 lines of communication that they will need to do. So say one member talks to another member, but the other 2 members need to be made aware of that, then you basically have 3 sets of reconciliations that needs to, sorry, you have multiple sets of reconciliations that need to take place between every single member there, in order to ensure that that state change was actually synchronized across the other members of the organization. The other alternative is that you could have an intermediary that actually runs the network on behalf of all the other participants, and so that intermediary is basically the blockchain. And of course, that's another valid approach, but the issue you have there is that what if they decide that they're going to up their prices, they're going to go out of business, or what they're providing a poor service. Blockchain provides for the members of the consortium basically a common interface for everyone to interact with one another. You don't need to go and define your own one, and that's a significant benefit associated with it. So one of the other questions is, can you illustrate a bit more about the underlying parts of the shared ledger? Do you mean one copy of the shared ledger for each of the relevant companies? So when we talk about shared ledgers, it does kind of get into what the underlying technology that's being used here. So say with an Ethereum network, every company that's running on an Ethereum network basically has a copy of all of the network's data. But then if there's private transactions that happen on the network, there's additional privacy information that those organizations that transact with one another will store. With Corda networks, it's slightly different in that the actual community, you don't have this notion of a single shared ledger. It's more, you have groups within the actual network that share common data that's relevant to the transactions that they have with one another. And Fabric as well, they have it's probably more analogous to what you have with Ethereum, where you have this kind of shared ledger, shared database or ledger piece, but then there's also the ability for point-to-point private transactions there as well. It's certainly something I could talk to in a bit more detail another time, but on the surface anyways, that typically when we talk about blockchain, each of the participants on blockchain networks, they have the same copy of the data, but there are privacy solutions to ensure that sensitive or confidential data is not shared with the other participants on the network, or if it is, it's in an encrypted form, so that these sensitivities that businesses have here are addressed. Another question, how do we achieve true decentralization? Most of the blockchain platforms such as Azure, SAP are initiated by a single party. Yes, it's a very valid argument. You know, if you have these very dominant cloud providers and, you know, all of your blockchains running on that single cloud provider, then, you know, you don't achieve true decentralization. But, you know, the great thing about blockchain is it provides optionality though for the members of a consortia to choose where they want to run the infrastructure. So it might be that they, you know, if they're a very large company or, you know, still doing things kind of pre-cloud, they've got their own server farms that they run and maintain themselves. Or it might be that, you know, they have a specific smaller cloud provider they want to use. You know, those options are still available there. And this is, you know, what's great about it is that it's down to the companies themselves to make those decisions. Now, I hope that answers the questions. You know, certainly, again, if, you know, using that link below, we can, you know, using a discovery session, I'd be happy to talk with anyone further about any of the things we've spoken about here. If you do, I can stick around for a few more minutes. Appreciate that I was muted for a little bit earlier, so we lost a tiny bit of time there. But yeah, I can stick around for a few more minutes for questions if anyone has any. Okay, well, given there's no further questions at the moment, we'll finish up the webinar here. As I said, if you head to web3labs.com/discovery, you can book a session where we can, you know, discuss specific opportunities for your organization. But otherwise, please do keep an eye on my my LinkedIn feed, connect with me. I'm putting video content out now as well regularly. There's a lot of useful information there. And yeah, I look forward to hearing from all of you soon. Thank you very much and goodbye.